Hyperbolic identities. So far we talked about hyperbolic functions and we introduced them. We took the derivative of these types of functions. Now we are looking for some identities. Remember that hyperbolic sine of x is defined as e to the x minus e to power minus x divided by 2. Hyperbolic cosecant of x is e to the x plus e to power minus x divided by 2. With the same definition, we taught hyperbolic tangent of x is hyperbolic sine over hyperbolic cosine, which in turn is equal to e to power x minus e to power minus x divided by e to the x plus e to power minus x. Now, what are some important properties of hyperbolic functions in general? So remember that when you talked about sine and cosine, recall, sine squared of x plus cosine squared of x is equal to 1. Or in general, sine squared of alpha plus cosine squared of alpha is equal to 1. Can we find some identity relation for sine, hyperbolic sine and hyperbolic cosine? Let us try to see how we can combine these together and get a 1 or unit on the other side. Let us check a hyperbolic sine to the second and hyperbolic cosine to the second of x. Let's see what's happening here. If I take hyperbolic sine and raise it to the second power, take hyperbolic cosine and raise it to the second power, adding them or subtracting them create a 1 for us. So a hyperbolic sine squared is e to the x minus e to power minus x divided by 2 to the second, which in turn can be written as e to the x minus e to power minus x to the second divided by 4. This can be written as e to 2x. So basically, we are going back to algebra. You can use the formula, or you can basically take this quantity, take these two binomials and multiply them together. Either is fine. So e to x minus e to power minus x times e to the x minus e to power minus x divided by 4 and see what you get. This is in turn equal to, if you take this quantity, e to the x and distribute it into parentheses, take negative e to minus x and distribute it into parentheses, what do we get? We have e to 2x and then minus e to the x times e to power minus x minus e to power minus x times e to power x and then plus e to power minus 2x divided by 4. But again, from algebra, remember that if you combine these two quantities, it is equal to 1 because e to the x times e to power minus x is e to power x minus x or e to power 0, which is 1. So this quantity is 1. This quantity in turns is equal to 1. So this can be written as e to 2x minus 2 plus e to power minus 2x divided by 4. So keep this one here. You have hyperbolic sine to the second power of x. Now, if I just start calculating hyperbolic cosine to the second power, what do I have? Hyperbolic cosine squared of x is equal to, with the same argument, you have e to the x plus e to power minus x divided by 2 to the second, which can be written as e to the x plus e to power minus x times e to the x plus e to power minus x divided by 4, or as we saw before, we can just distribute e to the x into parentheses. We can distribute e to minus x into parentheses here, distribute it, and then what do we get? We get e to 2x plus e to the x times e to minus x plus e to minus x times e to the x plus e to power negative 2x divided by 4. And as you remember, these are all equal to 1. So you can simplify this guy into e to 2x plus 2 plus e to power minus 2x divided by 4. So the question is, if I take these two quantities and add them together, do I get a 1? What if I subtract them? I'm trying to find the identity. So let us investigate how we can combine these and get a 1. So if you take hyperbolic sine squared of x and add it to hyperbolic cosine squared of x, what do we have? We have e to 2x. Let me use the same color. E to 2x minus 2 plus e to power negative 2x divided by 4 and add it to e to 2x plus 2 plus e to power negative 2x divided by 4, and then combine the denominator, which is 4. What do we create? We create 2 e to power 2x, negative 2 and 2, they get canceled out, plus 2 e to power negative 2x. This guy is not 1. So adding them is not helpful. What if I subtract them? All right. If I subtract them, if I subtract hyperbolic cosine squared and hyperbolic sines to the second power of x, what happens? Take a look. If I write down hyperbolic cosine to the second power of x minus hyperbolic sine to the power 2 of x, what do we get? Take a look. You have e to power 2x plus 2 e to power negative 2x divided by 4 minus e to power 2x minus 2 plus e to power negative 2x divided by 4. So if I combine these two together, what do I get? This guy in turns is equal to, if I take common denominator 4, I have e to 2x plus, okay, I missed something here. I jumped a little bit ahead. Let me move it a little bit here. This guy was plus 2 plus e to power negative 2x. I forgot to add this guy. Plus 2 plus, okay, perfect. So e to 2x plus 2 plus e to power negative 2x. And if I distribute this negative sign into parentheses here, or in this quantity here, we get minus e to power 2x plus 2 minus e to power negative 2x. Okay, now we see we have some progress. Why is that? E to power 2x, negative e to power 2x, they get canceled out. E to power minus 2x and minus e to power minus 2x, they get canceled out. What you end up with? You end up with 4 divided by 4, which is 1. We are happy here. Why? Because we just showed that the hyperbolic cosine squared of x minus hyperbolic sine squared of x is always 1. So this is the identity for hyperbolic functions. So you found a nice relation between hyperbolic cosine squared and hyperbolic sine squared, right?